Hi everyone. Thank you for joining me at Conference 42 DevOps 2026. My name is Ravi Babu Dasari from NetApp. Today I'm excited to talk to you guys about scaling microservices development, a shared cluster for developers to deploy their work and effectively delivering the SaaS work. Before we go there, a little bit about me. I'm a lead software engineer and architect at NetApp, based off of Greater Boston area. So I've been with NetApp for around 10 years. I've been working on SaaS products from the beginning. So I have experience in developing, deploying, and shipping the SaaS products, different features. I've been working with Kubernetes from about 7 years. So ship the products like Argo CD and GitOps driven rapid deployments. So we have very strong platform and everything. So most recently I've been into AI, but this presentation is a lot more about DevOps. There is a little bit of AI, we will see. So let's just jump right in. Okay. As microservices promise scalability, modularity, and rapid innovation, perfect for modern SaaS platforms, teams can deploy services independently, enabling faster feature delivery. But in reality, managing these environments for development and testing is a nightmare because there are hundreds of services. Even a small change requires thorough regression testing, leading to complex workflows, cross team coordination issues, and slow velocity. Traditional methods just don't scale efficiently. So, in the traditional model, we have dedicated clusters. We waste the resources because of that, and provisioning these services is pretty slow, right? So, let's take a look at a visual representation of a typical or traditional setup. Is you have on the top you have this cluster with all the services deployed of say 100 services, right? You deploy a feature branch in it, you take it for testing, you do all the development in it and deliver off once you're done, and you keep doing it. Sometimes you don't do anything, you keep these clusters. That's going to take more out of your pocket, right? They come with high cost, and you have alternative approach of say can rebuilds, right? So let's see why they don't work as well, right? So they're designed for production rollouts, not for development, because mostly you have just one canary deployment, not as many as you want, or as many features you're going to develop on. And it is complications with stateful services, because when you have a canary build, you can only manage up to a certain threshold of complexity. You cannot go beyond that. So that's another problem. And then what is the alternative for this? So that's what I'm going to talk about today. So we are going to use namespace-based smart isolation, right? In a shared cluster, it provides full safe separation for any number of feature branches simultaneously while still sharing unchanged services efficiently. So I'm calling it STDP, right? It's actually just a name. You can call it anything, but the Scalable Development Deployment Platform. It uses namespaces for isolation in shared clusters for secure environments, dynamic routing with the ingress and with the wildcard routing and whatnot, and also network policies and other things. We're going to go a little deeper into it. This balances the speed, cost, and safety. So let's take a little look at it. So when a developer pushes a feature branch, the idea of this STDP is automatically creates a dedicated namespace and applies your Helm overrides or what's a alternative for those, and giving each branch its own URL for testing. So you have single cluster but multi-tenancy, right? And the proposed architecture, if you see, is so you have those shared baseline cluster with all the unchanged services which are common across all your feature branches, right? It can be for some, it cannot, it might be unique for some, right? And then you have multiple namespaces for each feature branch, and you deploy only modified services or the dependent services, right? So that's the base idea. A little simplified, but we will talk a little more details and you'll get an idea. So the traffic routing is the key here. So you use ingress rules which are generated and are dynamic and are with wildcard, and you do some flexible verification switch routing to test against staging or production data by leveraging compatible baseline setups. So that is also a flexibility. So meaning you want to switch between different databases, you can easily do here. So that's also one benefit, right? Without having to do deploy or migrate the databases. So that's also a good thing. So on top of it, a web portal will make things more easy to use, right? So I have a working demo I'll show you guys at the end. For now, I'm just showing the snippets, right? See. Yeah. So at a high level, STDP has three layers: a management portal for orchestration and visibility, a service layer integrating with CI/CD via Helm, and Kubernetes infrastructure layer optimizing for multi-tenancy, right? Web-based development portal simplifies this. Developers, QA, product owners can create sandboxes, select baselines, and auto-generate namespaces and ingress manifests and network policies that they want to do. And this portal fosters collaboration by sharing feature previews across the teams, meaning people can share their demos across the teams they can access, and they can see how the new feature is, and just any other shared cluster. And not just that, but also a place for you to look at all the features, find it easily. The approach integrates with CI/CD pipelines, right? That's obviously key. Where baselines auto update, you keep on updating your baseline services with, say, production or staging the way you want it, and deploy feature branches only when you have changes. So there are like basically these three layers, right? Now, just to demonstrate, so even in a shared cluster, so names network policies ensure feature namespaces cannot talk to each other, only to approve baseline services, right? So the idea behind that is you will have an isolation between these services which are modifying and they only talk to baseline, that makes sure that you do not have collision of services and you keep as if it's a standalone service, right? So that's the main point of network policies. You have to make sure that you contain it, otherwise you'll have complicated issues. Okay, so the payoffs, let's talk about them. So you have a streamlined development with less overhead, because you can just go to that portal, create new clusters, shared clusters, and start making changes, push them, having QA test them, and review them with the PMs, and all these things are like run the automation suite on it and do whatever you want. And then at the end, once you're done, you can just simply get deleted. So it's actually cost effective, and the consistency in the environment makes it easy for you to switch between things. And you also, the earlier I said the database switch is also very useful, right? So the security is also good. You can update your role-based access in your AWS clusters and network policies. You can add centralized secret management. You can make sure that there is no collision. So those are the things you need to take care. So there are some issues with this, with especially stateful sets, some configs are the secrets, etc., right? Or you have some S3 bucket, blob storage or whatnot, right? That is one of the challenges. So the most services are stateless, very easy to isolate most of the time. But these services which are the outliers, like the databases, caches, and blob storages, introduces side effects if they're fully shared. For example, somebody is trying to add a new column that is not needed, or they're expecting a certain column which does not exist, or you are basically corrupting the database, right? So that's basically the biggest problem in a shared cluster that you might have already thought of, right? So this risks include like data corruption and interference across the branches, which is not something you would want to see, right? That's not exactly how the production with canary goes, right? So how do you balance the isolation for a safe testing with efficiency, right? So we handle this with smart change analysis. So you scan dev branches, the diffs of the dev branches to detect stateful impacts, right? If it's just a new endpoint with no schema change, share the database. If there is a migration, replicate it with the namespace, right? Tools include namespaces for segregation, ingress or service mesh for routing, connection strings, and cache isolation via keys or instances, right? So automation is the key. So what I mean by that is you can manually select, you can choose which service needs to be replicated, which service can be used by the shared service. But if you can automate it with AI now, because the LLMs are getting pretty smart, and you can write a nice agent that can pull all the diffs for different repositories and figure out how the dependency can be, and if they need to be deployed separately, meaning any stateful service, or do they have to do, can they use a shared service? So based on your change, it can figure that out. So for example, imagine you have three services, a front end, an API layer, like a middle layer, and a database, right? So you made a change, you added a new API endpoint, and does not modify or add a new table or column or example, right? So you can just spin up a new API service, don't have to even replicate a UI service. So you can still use a shared UI service, shared database service, right? You can just deploy the API service, just one service out of all three, right? So imagine the same situation in hundreds of services. So that would save you a lot of time. So the analysis in a little, if you want to visualize it, how it goes is, so first you start analyzing the code changes. So find out impactful stateful services, right? And then you can figure out which service needs to be replicated in the namespace and which services can be shared from the baseline, right? And then based on these decisions, you can create your ingress routing, right? And then once you decide what you want to do, you can deploy. So this is just a code snippet to and a pseudocode to see how we can do it. So figuring out if you have to create a replica or can you use a shared service. Yeah, so the platform so for example, this is a dynamic connection string routing via environment variable injection. So you can figure out dynamically add which route you can use with the ingress routes, and you can probably you can play with some environment variables, or you can have your portal or your service that can add the manual routes to the ingress, whichever works. So resource quotas, just to make sure you don't have some bad feature that is hogging all the compute you have. Just make sure you don't forget about resource quotas, right? Just, and that also helps you contain any damage that they could do in terms of slow systems, right? As I said, you will have to integrate with the CI/CD pipeline for this. So whenever you have a commit trigger, you can build packages, and as soon as you do that, you can you can talk to STDP APIs to deploy that service or the changes, and by analyzing what needs to be done, and then you test and validate. You run your automation suite for that, right? I've been using, by the way, this solution in NetApp in my team, and it's been quite useful, right? So it's saving us a lot of time. The build happens, you have the images ready. As soon as you deploy it, it's done in a second, right? There is no provisioning needed. You don't need to talk. You can spin up new clusters on the time, all the time whenever you need, and you can just delete them if you're not using it. So you just, when you're testing, you just spin it up. When you're done testing, you just delete it. You're not going to keep it for a long time. So your testing cycles will be shorter as well, and we are utilizing your resources at the maximum efficiency possible. So that's a big achievement, I would say. So this enhances the team collaboration too. And some considerations we already discussed. So resource quotas, ingress strategy, data management, we talked about it. You can add additional logging and analytics on top of it and observe better. So that's also something you can do. So how do you adopt? So before we go into adoption, I would like to show you some demo quickly, and then we can just talk about some things, next steps that you guys can take, right? So first, let's take a look at this. You guys can, okay, I hope you guys can see. All right, so this is, I'll share you guys the code for this. Let's see if this works. No, it's not. Let me go to my VS Code and start this quickly, if you don't mind. All right, so you can see this, just deleting this existing clusters. You can see the portal here, right? All right, so the idea of this, so this is a portal where you're creating the dev shared clusters, right? So here I can pick my feature branch, for example, user auth. Right? So this is my dev branch. So I can choose to deploy a service from here. For example, I choose to deploy just a front end and a back end, not the API, or maybe just the API, not the backend, right? I'm deploying it. So you can see it's gonna deploy. It's not provisioning a new cluster. The cluster already exists, which is a shared cluster, right? So you can see now my demo is up and running already. Okay. So I launched it. Let's see what are we gonna get. So you can see it says I have deployed a front-end service, which is user auth, and it has a backend service. So let's figure out which backend services by calling those API calls. You can see that backend is the default, which is the baseline, but the API service is from user auth. So let's take a step back and let's do the backend this time, but not the API. So security auth, sorry, security patch, and I deploy this one. So let's see, once we have this up and running, let's just launch it. That's up. Okay. So this is security patch, and this time let me call all the services. So you can see now this time baseline API service is the baseline, but the backend service is security patch branch, right? So UI front end is anyway security patch, right? So you can deploy just the backend as well, but you get the idea now, right? So now I have the code base here. I'll share the link with you guys. This is just implementing a part of the solution, but there's more to it. A real solution requires a lot more, right? I can quickly take you guys with the code, but I think I'll give you access to the code base, you can see. But let me show you another interesting thing, right? Yeah, so this is the Rancher desktop. I'm using my desktop for this. So you can see the ingress routing. I just want to show you an example, right? So we just created those features deployments, right? So you can see that here this security patch is deploying both front end and the back end, but the user auth branch is actually deploying front end and API services only. The routes are routed like this, but you also see the default routing for the API to be the base API and the backend to be the base backend, so that these feature branches are routing properly, right? So you get an idea. So this is the basically the magic sauce. On top of it, you need so many layers anyways, but that's the idea. So now let's talk about the adoption, right? So adoption is not easy if you want to do it at once, right? It has to be in a phased manner, right? So pick and choose which services are best suited. So put them in the shared ones, which are easy to do. For example, you have a UI service, very easy to do. Some services, very few dependencies, they're easy to do. There's some which are stateful ones. You want to replicate them until you get to a position where you can actually share them as well, right? And then you automate it, you add the security and all the things, and then keep scaling it, migrate one service at a time. Yeah, so this definitely transforms the development workflow. It definitely is gonna be very useful for all the people. And I have been using the solution that I deployed across the teams, QA and PM. They've been very happy with this, and I've been maintaining it from 6 years, keep on doing patches and updates. The solution that I proposed is a lot more complex one in this demo, in this presentation, but I think that you get the idea. Okay. So your deployment portal is the key, your command center for you. You can make it custom tailored for you, right? And then, yeah, I think the remaining slides are pretty much what we spoke earlier, the demo you have seen just now. And if you have any questions, do definitely send them across to me, either via LinkedIn or my Twitter or X. So yeah, it was nice presenting my idea to you guys. I hope you like it. If you have any feedback, it is very valuable to me. Do share with me. Thank you so much.